it occurs to me that we might have another interesting question right here that I didn't consider. I said, well, all right, I took $6,500 and invested it for 5 years, and I found I got $7,741.13 as the result of that. But you might have a bank account. You might ask yourself, well, all right, if I took $6,500, I might want more money. Let's say I was interested in finding out, well, how long would it take me if I had this account to build up to $10,000, right? How would I know? Well, this is an example of something that we can actually work out. So let's say we add this on. Let's say, how long would it take me to accumulate $10,000 in my account? What would I have to do? That's a $10,000 for my account. So my account balance in this case is that. And if I'm asked how long, of course, that's a question that asks me, well, how much time t are we really talking about right here? So let me help you set that up. That means that we're going to say, well, $10,000 is going to equal $6,500 times 1 plus 0.035 divided by 12 raised to the 12 times t amount, right? So how could we work this out? Well, we need to do a couple of things. Of course, we want to simplify inside our parentheses right here on the right-hand side of our equation, which we're going to find is 10,000 would equal 6,500. Now you see why I wrote my letters up here. 1.0029167, all rounded off there to the 12t. Well, what we've got now is an exponential equation that we can solve. And what we're going to do is that we want to isolate the exponential part of this by dividing both sides by 6,500 right here in order to handle that particular problem. So I'm going to divide both sides by 6,500. What happens here is that this divides out, these divide out. I'm left with 100 over 65. I'll just work out the number though for us. So let's see, if we took 100 and divided it 65 ways, that would give us 1.538 something or other. So let's go with that, 1.538. Let me get a couple more digits out of that. 4/6. Let's go to 4/6 right here. So 4/6 is equal to 1.0029167 to the 12t. And if you don't remember what we did with this kind of thing, this was where we took a natural logarithm on both sides, or a common logarithm. Depends on our opinion here. But let's go with the natural logarithm. I'm going to take my natural logarithm of 1.53846. And I know the reason I would take my natural logarithm over here on the right-hand side, it would be because I would want to take that power in front. Because when I take the natural logarithm of my number over here, I can take this exponent down in front so that the natural logarithm of 1.53846 is equal to 12t times this natural logarithm. Okay, so how would I do this? Well, one thing that I could do right here is divide both sides by this logarithm. So I'm going to divide the left and the right by this logarithm. And I'll note that I now would be able to find this particular value and divide it by 12 in order to solve for t. And of course, when I find that value, I get t is equal to 12.26 years. Well, 36 years, pardon me. The 0.326 years. Good Lord, can't even keep track of my own calculations. 12.326 years So 12 and a little bit over a third of a year, right? So we would say, if well, approximately 12 and 1/3 years later, I would have $10,000 to my name, starting out with 6,500. And sometimes that's a really interesting question to know. Okay, more to come in the next video.